Alright, let's go over the reaction order and rate law expression practice worksheet. So given the following equations and experimental data, you have to write the correct A, rate law expression, B, the reaction order, and C, the K value. Let's start with number 1. Alright, number 1, you're given A2 plus B2 is going to synthesize into 2AB. So, as per the rule that says we always exclude everything but the reactants in the rate law, we can disregard this part. So let's start by finding out the rate law expression. So the rate law expression is found first by calculating the orders of the given concentrations of A and B. Let's start with A. A. We want to find two data sets for A that changes on the concentration of A but does not and stay constant in B. So the only two data sets given in the table that satisfy these requirements is 2 and 3. In 2 and 3, the value for concentration of A changes from 0.001 to 0.003, and the concentration value for B stays constant at 0.004. Alright, using this information, we can set it up. Parentheses, we want to put the highest number first, concentration 0.003 over 0.001, right? We just grab these values and put it on the fraction form. So if we're looking at the concentration order value, we want to look at x exponent attached to this. That will equal to the rate corresponding. So 0.003 corresponds with 0.36, and 0.001 will correspond to 0.04. So the fraction will always have the same thing on top because our same experiment data values on top. So since 0.003 is on top, 0.36 is going to be on top as well. And since 0.001 is on the bottom, 0.04 will also be on the bottom. Alright, so how to solve this? Well, all you got to do is type this into your calculator, which will give you 3. X, carry down the x down, equals, divide this into your calculator, this part right here, and that should give you 9. So from this, we can tell that x is going to be 2. So this is second order. Alright, let's take a look at B. B. Same process for here, the same exact math principles, except we use different numbers. So this time we want changing for B, concentration of B, and A, concentration of A, to stay constant. The only two data sets that accomplish this is 1 and 2. In 1 and 2, the concentration of B changes, and the concentration of A stays constant. Same rules as the first set. We want to put the highest number on top, 0.004, and 0.001 on the bottom. Or sorry, 0.004 on top and 0.001 on the bottom. This time we're solving for y. And since 0.004 corresponds with 0.04, 0.04, it goes on top. And the bottom 0.001 corresponds with 0.01, so that goes on the bottom. So all you do here now is solve. Plug this into your calculator, and that will give you 4. You put y, carry down the y, and this will also give you 4. So then we can already tell y equals 1. So that is the first order. Alright? And so the rate law expression is written using the orders and the concentration. So the equation for rate law we'll put on top. Rate equals K times the concentration of A to the X and concentration of B to the Y. So since A here is concentration, we can write as follows. Rate, here I'll write it in a different color. Rate equals K times the concentration of A2, because the variable here is A2, to the second order and concentration of B2, as per stated in our original equation, the first order. That is our first part. Second part asks us for the reaction order. The reaction order is basically the sum of all orders. So we take the sum of the order of the A, concentration of A, which is 2, and the concentration of B, which is 1. 2 plus 1 is 3. So then the total reaction order is 3, so third order. All right, C. The K value is calculated using your rate law equation that you found in question A. So what you got to do is all you got to do is just take one data set from an experiment. I always like using the first one because it's the first one and it's easy to remember that way. All you got to do is plug in this for concentration of A, this for concentration of B, and this for the rate. All right, let's try. So rate 0.01 equals K times the concentration of A, which is 0.001, 0.001, and then we carry over the order, which is 2, second power, times concentration of B, 0.001, to the first power. So all you're doing basically is, we'll write it here, taking 0.01 divided by um, uh, basically 0.001 squared times 0.001 to the first power. That is basically all you are doing. So what we can do is type this into our calculator and grab that number and take this number and divide it by that. So basically all you're doing is 0.01 divided by the squared value of 0.001 times the 0.001. Since it's first power, you can ignore the first power. It's the same number. So your final answer is going to be 10 million. 10 million. And the units for this, the key thing is the unit is always going to be unit equals m to the negative q or negative question mark s to the negative 1. Question mark equals reaction order, total order, the overall order minus 1. Minus 1. All right. So our overall order we calculated was 3. So therefore, our unit is going to be m, and then 3 minus 2, or 3 minus 1 is 2, and then s negative 1. That is our first question done. All right, let's go over the second question. So we are given C plus D becomes E. So we can ignore this E because of the rule that says that we can only have reactants on our rate law. Let's calculate C first. C. So we want to see what two data points that match our criteria. We have to have C that changes and D that remains constant. So 2 and 3. So we take the bigger number. Bigger number is 0.3 over 0.1 to the x, and then the corresponding values of the rate for the experiments that we chose. So 0.8, 0.08 over 0.08. All right. So all we got to do is divide this and you get 3x, and divide this and you get 1. So we know that the x is going to be equal to 0. Yep, 0th order. Next, D. Let's write that in a different color actually. 0. 0th order. All right, so D. Same process. We get the values that where D changes, but C remains constant, which is experiments 1 and 2. Always put the higher value on top, 0.04 over 0.01. to the y this time equals the rate. 0.04 corresponds with 0.08, and 0.01 corresponds with 0.02. So since 0.04 is on top right here, we're going to put the corresponding value, 0.08, on top. And for 0.01, it corresponds with 0.02, so we put that on the bottom. And all we do is we plug this into the calculator. So we get 4y this time equals 4. And therefore we know that y equals, different color, the first power. First power. All right, so now we can write the rate law. Let's write that in a different color. So A, rate law. Rate law is always rate equals K times concentration of A to the X times concentration of B to the Y. In our scenario, A is C and B is D. So we can do this. Rate equals K times the concentration of C to the 0th times concentration of D to the 1st. And that is our rate law. B asks us for the reaction order. The reaction order is all of the orders combined. 0 plus 1 is 1. So the overall reaction order is going to be first order. C asks us for the K value. All we do for the K value is we plug it in. So let's take a look. We get the first data set. I always like using the first data set. And we plug these values into our A. So we're given rate equals, rate is 0.02 equals K times the concentration of C, 0.1 to the 0th, times concentration of D, 0.01 to the 1st. All right, so this cancels out right here. This cancels out because anything to the 0th power is 1, and when you're multiplying by 1, it stays the same. So this actually becomes 0.02, and then we know that 0.01 to the first power is itself, so 0.01 K. So all we do here is divide. Same process as what we did up here. It's just nicer numbers, 0.01, and our K value becomes 2. So we can bring that over here, and we can say that the K value, the rate law constant value, is going to be 2. And for the units, as I've said, the cheat value, the m to the negative question mark, s to the negative 1, we take our overall value, which is 1 plus 0, which is 1. And since we don't have since 1 minus 1 is 0, we can only put the s to the negative 1 on here. So our unit for this is going to be 2 to the s minus s, 2 to the s, 2 times, 2s to the negative 1, and that is our final answer. So if you're confused by that, this is 2 to the, then the unit is s to the negative 1. So number, unit. All right, let's try number 3. Number 3 is F plus G combines into H. Same process, let's calculate the orders first. The F orders are going to be, we're going to look at, this time we have 4 points. So we want to look at the ones where the F changes and G remains constant, and G changes and F remains constant, vice versa basically. So let's start with F. We know that this changes here, and this remains constant. So we want to use these values. If we were to use 3 and 4, we would recognize that G does not stay constant while F stays constant. that would be what we want to use for the G part. So if we were to get the bigger number on top, 0.03 on top, 0.01 on the bottom, to the x equals the corresponding values. So 0.03 corresponds with 0.06, and 0.01 corresponds with 0.02. So since 0.03 is on top, 0.06 goes on top as well, and 0.01 is on bottom, so 0.02 goes on bottom. So when we get our calculator, we can get this. It becomes 3 to the x equals 3. Then we can tell that x equals 1. So, different color, first order. All right. For the G part, same process. G, concentration. And we want to look at now the data points where G changes, but F remains constant. We talked about this in the beginning of the problem. This one has G changing, but F stays constant. So if we were to get the values, the bigger value on top, 0.06 over 0.02, to the Y equals 0.1 over 0.1, or sorry, the corresponding values for 0.6, 15 on top, and 5 on the bottom. All right, when we solve this, we get 3 to the y carries downwards, equals 3. Therefore, we know that y equals 1, so first order. All right, now we know all the information, so we can go ahead and solve. So A requested that we find the rate law. The rate law base equation is rate equals K times the concentration of F, or in this scenario F, times to the X times the concentration of G, which is B in the other equation, to the power of Y, the order. So rate equals K to the concentration of first F, which is the first order, and G to the first order as well. And that is our rate law equation. B states that we want the total overall order for the reaction. 1 plus 1, since it's adding all the orders up, is 2. So second order overall. C asks us to find the K value, the rate law constant. Our rate law is here, so all we got to do is plug it in. I always take the first set of data in the experiment and plug that in. So we take rate 0.02 equals K times the value of F 0.01 to the first power times G value, which is 0.4, 0.4 to the first as well. And so when we get 0.01 to the first, it becomes 0.01, and 0.04, or sorry, 0.4 to the first order, it's also 0.4, it's just itself. So when we multiply 0.4 by 0.01, we get 0.004. So it's going to be 0.02 equals 0.004 K. And all we do here is just divide here on both sides by 0.004. And our K value is going to end up as, the K value is going to end up as 5. 5. So we grab our 5 and we can put 5 here. And since the cheat value for the unit says that it's m to the question mark, which is the total order here, minus 1, it's m to the negative 1, and then s to the negative 1. So that is going to be your final answers. All right, last question. Scroll down a little. So we're given this equation, I plus j, it turns into L. So what we want to do is we want to start by calculating the concentration order values. So we'll start with I. We want to look at the two data sets where I changes but J remains constant, which is only seen in experiments 1 and 2. So we take the higher value of concentration of I that changes 0.03 over 0.01 to the x equals the corresponding rate values. So 0.04, or sorry, 0.54, 0.54, which corresponds with 0.03, which is on top, over the 0.02, which corresponds with 0.01. And all you got to do is plug this into your calculator. So when you plug this into your calculator, you get 3x equals 54 divided by 2 is 27. So we know that x equals 3. Third, I'll write that in a different color. Third order. All right, so let's calculate it for j. Same process. We want the two data sets where j changes but I remains constant. So the only one that does that is from 0.2 to 0.6 and I staying constant at 0.1. So we grab the higher number on top, 0.6 over 0.2 to the y this time equals 0.6 corresponds with 45 and 0.2 corresponds with 5. Since 0.6 is on top, we put 45 on top, and since 0.2 is on bottom, 5 goes also on the bottom. So 0.6 over 0.2 is 3 to the y carries down, equals 45 divided by 5 is 9. So we know that y equals 2. Different color, 2. Second order. All right, now we can write our answers. We can write our rate law. So starting here, rate law. Rate law is rate equals k times the concentration of A, which in this scenario is I, to the xth power, xth order, and B, concentration of B to the yth order, which is, in this scenario, we figured out both of these. All right, so writing it is going to be rate equals k times the concentration of I to the third order, third power, and then times j to the concentration or to the order of 2 to the second power. That is your rate law. B asks us for the reaction order. Total reaction order is calculated by adding every order up. So 3 plus 2 equals 5. This is the fifth order overall. C asks us to find K. All we got to do is plug our first set of data points, or any data point, but I like using the first, into our A rate law that we found here. So let's do that now. Rate 0.02 equals K times the concentration of I, 0.01, to the third times the concentration of J, which is 0.4, to the second power. All right, so when you grab your numbers into your calculator and do 0.01 to the third, you get a very small number, and you multiply it by the squared value of this 0.4 squared, and you will get an even more smaller number. So we're going to have 0.02 equals 7 zeros. Wow. 0.0000567 zeros and a 16 k. So all you got to do is divide it by this number, big number 0.000000016, and divide it 0.000000016, and in the end you will get 125,000. 125 0, 0, 0. All right. So we grab that number, 125,000, and our unit hack is m to the negative question mark, which is the total overall order minus 1. 5 minus 1 is 4. M to the negative 4, and then s to the negative 1, and that is our final set of answers. And that's it for this worksheet.